Illustrate the communication process using a block diagram and explain each component in detail. Explanation of components. Sender initiates the message and converts it into a transmittable format. Encoder converts data into signal forms suitable for transmission. Channel, medium through which the signal travels, for example, copper wire, optical fiber. Decoder reverts the received signal back to data form. Receiver accepts the message and interprets it. Feedback confirms successful data reception. In data communication, different modes of transmission are used based on the communication requirements. Explain the 3 modes of data transmission, together with suitable examples of applications for each mode. Data transmission. Definition. Example: simplex, data flows in one direction only. Keyboard sending data to the monitor. Half duplex. Data flows in both directions, but not simultaneously. Walkie-talkie communication. Full duplex data flows simultaneously in both directions. Phone conversation. Question 2. Define attenuation and discuss 2 techniques used to mitigate its effects in wired and wireless networks. Definition. The reduction in signal strength as it travels through a transmission medium. Techniques. Signal amplifiers/repeaters. Error correction codes. ECC. Directional antennas. A university campus network utilizes a combination of optical fiber and wireless media to support its communication infrastructure. Explain 2 advantages of using optical fiber. 2 advantages of using optical fiber. Data speed, extremely high, up to several gigabits per second. Security, immune to electromagnetic interference, difficult to tap. Distance, low attenuation, allowing long-distance transmission without repeaters. The wireless network frequently experiences interference. Identify 2 possible sources of interference to the network. Other wireless networks operating on the same frequency. Physical obstacles like walls or metal structures. A small retail store wants to connect its cash registers, computers, and printers to a single network to facilitate file sharing and sales reporting. Identify the most suitable type of network for this setup and 2 justifications of your choice. Local Area Network, LAN. It is ideal because it covers a small area and provides high-speed connectivity for data sharing and printing within the store. Recommend a suitable network topology for the store and explain 2 reasons for your recommendation. Star topology. 2 reasons. Easy to add or remove devices without disrupting the entire network. Faults in one device do not affect the rest of the network, enhancing reliability. Question 3. Define network latency and identify 2 factors that can cause high latency in a network. Definition. The time delay experienced in data transmission from the source to the destination. High latency can lead to slow data transfer, lag in video streaming, and poor performance in online applications. 2 factors that cause high latency. Network congestion. Excessive data traffic can delay data delivery. Physical distance. Longer distances increase the time it takes for data to travel through the network. Discuss the 2 types of encryptions in preventing unauthorized access to data. 2 types of encryptions. Symmetric encryption. Uses a single key for both encryption and decryption. Example: AES, Advanced Encryption Standard. Asymmetric encryption. Uses a pair of keys, a public key for encryption and a private key for decryption. Example: RSA. Differentiate between signature-based IDS and anomaly-based IDS. Signature-based IDS detects known threats based on predefined attack patterns or signatures. Anomaly-based IDS identifies unusual patterns of behavior that deviate from normal network activity, potentially indicating unknown threats. Describe the purpose of a Service Level Agreement, SLA. in network management and explain the two key performance indicators that are typically included in the SLAs. SLA. An SLA is a contract between a service provider and a client that specifies the level of service expected, including performance targets, uptime, and response times. KPI, network availability, the percentage of time the network is accessible. Response time, the time taken to resolve a network issue or respond to a service request. List 5. Key components of network management. Configuration management. Maintains network device settings to ensure consistency. Performance management. Monitors network speed, uptime, and data throughput. Fault management. Detects and resolves network issues promptly. Security management. Protects network resources from unauthorized access. Cost management. Tracks and manages network-related expenses.